So this is the revision of my 460 final project, the first update video. These are the goals that we had. I had sent these in an email, and they are tentative right now. They might change as the project goes on, but this is the basic idea. So to meet some of the ABET standards or whatever. So what I'm basically doing is modifying the MTSP problem that we looked at in class by adding additional, like, for example, there wasn't a maximum time per salesman in the existing MTSP. So I'm going to go in there and I'm going to add that. And I'll show you more of how I'm doing that when I get to the MATLAB code. And then what's the business application of this? It's a scheduling problem. It's basically a more advanced or a more complicated TSP, which is how, most of those problems that we've looked at in class they expand to be a little more difficult once you start real world applications. So this is applicable to logistics and scheduling for shipping companies like Amazon, FedEx, UPS, the United States Postal Service, stuff like that. And an example of a kind of question that might be solved using this problem is how many trucks do we need to send to an area to stay above, whatever your service rate is, while still minimizing the cost. And so this is some of the technical application. You had said in your email that I need to be able to demonstrate a high level of understanding of the heuristics behind it. So like I said, I'm going to build in the MTSP. I'm going to modify the logic behind the route selection to eliminate the routes that exceed working hours per driver. And I believe I've already done that. And then I'll be creating a cost function to describe the cost of varying drivers. I kind of like to add another for loop in there to let the software determine the optimal number of drivers instead of manually inputting it as it's written right now. And I also would like to add the option to not visit the sites that are currently that are extra costly in the delivery routes. So if you have a 98%, if you need a 98% service rate, we want to be able to not go to certain locations if they're too costly. So basically, I want to add a monetary value to a percentage for the service rate. This is my log of the changes that I've made to the TSP code. So the first things that I did was I went through and added the different variables that I needed to work with. So we've got the overtime cost and then the maximum time for each of the salesmen. And then more of initializing those right here. I ended up going back and changing that at a later time. I enabled the seeds for repeatability so that I would get the same map every time. And then I went through kind of line by line in this code and made notes off to the right so that I understood what exactly the code was doing. Well, I wrote my own TSP code. Everybody writes code a little bit differently, so it was necessary to go through line by line to figure out what's going on. And then I have added a statement to an if statement to calculate whether or not the route of a single salesman is greater than the maximum time allowed, and if it is, there's a large time penalty or distance penalty incurred in order to eliminate that route from consideration. And then I've also added an if statement to say that if no optimal route can be found, if there aren't any routes that are under the allotted maximum time for however many salesmen, then the entire function will break and what it'll display use more salesmen. Here's the MATLAB code that I have so far, and following the change log, I've added the max time, the overtime cost, enabled the seeding so we get something consistent, more initialization of variables, and then we'll jump down to 260. Okay, and so right here was the initial code was just setting the TM at S is the number of salesmen, equal to D at S. And so rather than just kind of blindly accepting that, we're adding the criteria where if it's DS is greater than the maximum time, then we're going to set that equal to M, which is this very large number. And if it's not, then we set it equal to each other, or equal to ds again, tm equal to ds, as we did in the previous. And then down here, we're going to evaluate that. So right here, we're finding the minimum total distance of the route. And if after we calculate that, we're asking the program if the min total distance is greater than m, which is our very large number, our huge penalty, then it's obvious that with the number of salesmen that we have, we can't meet all the locations and still be under 10.5 or under your max time for the salesman. And so then going forward from here, what I'm going to do is add the service rate into consideration here, and actually in the previous one too. So I want to give the program the option to ignore a city or ignore a stop in order to bring that total distance under your M, or your very large penalty. And that's all I have so far. I'll send you the documentation and everything with it. I assume this is the first. I'm really just looking for your feedback at this point. I know I'm not done with the project or anything, but I'd like a little bit of guidance and what direction to go next. Thanks.